But I will try to share some of my enthusiasm for the next 5 to 10 years that could be truly earth-shattering. Let me get out of the way so I don't stand in front of the slides. Earth-shattering in terms of its impact on the economy, on the social fabric of our lives, and on the future of humanity. And that, I think a number of you are going to be talking about this over the next 2 days, but when we move from the automation of work to the automation of thought, to the automation of what we think is essential elements of what it means to be human, we're, I think, at a watershed moment for humanity, and one that I sort of fetchingly try to hint, iterating the superintelligence. What I'm going to mainly talk about is what's actually happening here and now and in the next few years. But it will hopefully set up the stage that we'll all increasingly believe, if you don't already, that this could be a natural path to iterate to capabilities that exceed human understanding, certainly, and perhaps exceed human capabilities on the margin, certainly, perhaps in totality. And that last part, of course, is the open question. Is it a generalized human intelligence? But I'm not going to spend much time on the sci-fi futures unless you want to in Q&A. What I want to try to share with you is, and I'm going to try to, as best I can, tweak it to what might be interesting from an economics and policy and sort of global perspective. A point of view is share what we're seeing from the startups we've invested in, the companies that we are privy to in terms of their timelines and what they're doing, and where this is all going to take us. In addition to the companies that you heard mentioned, I'm also on the board of Tesla, and so the autonomous driving impact over the next few years from companies like Tesla and Zoox and others on employment is profound, to say the least. There was some analysis I did a few years back with Eric Jurvetson and others that that perhaps of those who have a job globally, just under 20% drive for a living. It's just kind of a chilling statistic. But I move on. Let me first share something, and I want to ask a question just to get people physically moving. How many people have seen or are familiar with Ray Kurzweil's version of Moore's Law? This is the 120-year version of Moore's Law. It's when you abstract it and say, well, how much computation does a dollar buy? Okay, wow, so maybe 20% of the room. So let me just show it because I think it's super important to everything I've ever done in my career. And once I set it up, I would make the argument I think it's the most important thing ever graphed. And Ray Kurzweil and Werner Vinge get credit for this, not me, but I've updated the graph to today. So what are we looking at? Logarithmic scale. It's a little dim, but just it says calculations per second for constant dollars. So no one buys transistors. No matter what Intel might want to tell you about Gordon Moore and the origin of Moore's Law, as it's called, there are no customers of transistors, other than the belly of the chip industry. Everyone buys computation or storage. You can plot either, and you see the same curve. But over 120 years, they're very different epochs. It's not Intel by any means that existed for 120 years. That goes without saying. And each of these are very different technologies, from mechanical devices to relays, integrated circuits, and such, right? Different categories of time. Nothing to do with what everyone, let's say from George Gilder onward, thought was a specific phenomenon of the semiconductor industry. There's something about the faster, better, cheaper miniaturization of silicon that's so magical in the last 30 years. It transcends that. So each dot represents the best price performance computer of the day. Again, logarithmic scale, so every tick mark is 100x, right? Kind of astounding, and I'll add the labels. Just one more. Should go one more. Huh. This just died. Oh no, it just had it must be a PC. Yeah, they still haven't figured out how the map works. Very different machines. Machine that calculated the census in 1890, the machine that predicted Eisenhower's win in 56, the Nazi Enigma code cracking machine that, for those of you who watched Imitation Game, the Brits used during World War II. No one knew they were on the curve in the early days. No one was like some people argue Moore's Law is a self-fulfilling prophecy because people are building to the curve. That's just not true, right? No one knew this was happening. Now, for the economists in the room, notice it's kind of profound. It's exogenous to the economy, as some would think, right? World War I, World War II, the Great Depression have had no impact in the long run on humanity's capacity to compute. What is it about this compounding capacity to compute that continues unabated with economic cycles? Now, these companies come and go, right? They have all kinds of disasters befall them, right? It's like a baton handing off. And perhaps most importantly, with the updates that I've added to Kurzweil's original analysis, Intel has not been on the curve for the last 10 years. Right? Computation has shifted to GPUs. In fact, when Intel says we're hitting the red brick wall and Moore's Law is coming to an end, just don't listen to them. They've relinquished the right to talk about Moore's Law a long time ago because they aren't leading it anymore. And NVIDIA is, and soon it'll be the TPUs and dedicated silicon for machine learning. We didn't know to put those NVIDIA GPUs on there as a standalone processor until it became obvious, starting at the University of Toronto and elsewhere, that with Hinton and others, that these are the compute engines we want to use, and then soon customized silicon for deep learning and machine learning. And it is relevant because currently at Google, about 90% of all code generated is generated by a machine. And that's an indirect way of saying it's a machine learning or deep learning algorithm in terms of the code base. It's not human purposeful design. And that was going to be the the software industry writ large in the near future. We are going to generate code autonomously, and that's what I'm going to talk about most of the rest of my talk. We're going to train AIs. We're going to, train iterative algorithms to do our bidding. We're not going to program them purposefully like we did in the past. By analogy, it's as if the notion of programming is shifting to parenting, and I'll go through that metaphor a bit more in a moment. The main point I want to take away from this is A, the baton keeps handing off. B, it hasn't stopped or slowed down. C, when Santa Fe Institute looked at this, they saw it as a double exponential as the best, what line best fits this as a polynomial, as a single exponential. And I think most of all, it's profoundly provocative, almost a cosmological point of view. What is it? Why? Why does this happen? And I'll try to come back to that in a moment and offer at least one point of view as to, why do we see computational and all of the adjunct industries, gene sequenced and gene synthesized similar curves because they're computationally driven. In fact, when more and more industries have a certain degree along the vertical axis of computational power that it takes to simulate what they do, they move from trial and error experimentation to simulation science. So you see how this in automotive design. You don't need to crash cars to know how the crash tests will perform. You just do it for the government regulation at the end, right? If you want to design an airplane, you don't use wind tunnels anymore. Computational fluid dynamics has gotten good enough that ever since the Boeing 777 onwards, there's no wind tunnels use whatsoever. And that allows you to iterate at the pace of a software engineer, right? Very quick product iterations in a simulation rig, come out with a better product out of the chute, or have it work the first time, as many of the SpaceX rockets have done, to the marvel of others in the space industry that weren't so simulation-centric. So this is super important. I think over time, it will affect every industry. When they move from that, it was hard to simulate, to now we can simulate it. I think biology and biotech is at the cusp of that, and your next speaker will speak to some of that specifically, but I think that's the next great industry that's in the midst of this transformation. So, super important. I will reiterate, I think it's the most important thing ever graphed in the history of humanity, and in Q&A, I'd love if any you see a lot of graphs. Anything that's more descriptive of the future, anything that's more important to humanity, and true. I mean, maybe the economists won't like that, but I like that. Okay. I've mentioned this already. These are some of the industries we have been investing in over the last 10 years that we think are going through a profound change, where a new entrant comes in, like Tesla and automotive or SpaceX, in a sector that frankly hasn't had a new entrant for decades. In the case of meat manufacturing, not for hundreds of years. Has there really been a fundamentally different way to manufacture meat, without the animal? Or or you can see the competitive response to SpaceX or Tesla is largely one of the new entrants have the game, the incumbents are rolling over. And so this is going to be increasingly the economy at large. So, black swan events for those companies and industries, disruptive new entrants, restructuring the playing field will ripple through every industry. I think agriculture and construction and fintech are next. So here's one just really loosey-goosey hand-waving. I love showing this to a bunch of analytical, rigorous minds. Okay, here's one theory for why we have acceleration in technology. And oh, by the way, well, I'll mention a comment at the end. So first, what is this on the page? So you could think of, first, a lot of folks have recently made the argument that every idea is a recombination of prior ideas, right? That we sort of stand on the shoulders of giants metaphorically. That the Tesla, Edison, Marconi had all this prolific invention that they could do at the time because all the predecessor ideas that fed into electricity and magnetism being so powerful for AC motors and radio and what have you, the time was ripe. And simultaneous inventions occurred across the planet within weeks or months of each other. Right? And classic, horse race, if you will, in this. I see this as a venture investor. It is astounding how any major breakthrough or idea is quickly replicated by at least 20 to 100 other companies, often overfunded by venture capitalists. It's not an anomaly, it is the norm. So if you use this simple metaphor that every breakthrough, with rare exceptions, right, like a completely novel idea with no predecessor or antecedent, is in fact a recombination of recent interesting ideas, sometimes from different academic disciplines and such, and that makes them more powerful, then you can think of this as a combinatorial explosion, like Reed's laws, that if you just take the subgroup of ideas in idea space, let's say there are just n ideas in the world, the number of subgroups you could form of 2 to 3 or 4 of these would grow roughly to the nth power, a form of an exponential, or at least something that would grow quite dramatically. Now there's some dampening effects on here, so we're not really sure if it's 2 to the n, but it gets you potentially explaining why, and this might just continue, and why the internet is globalizing it, and why all these isolated pockets of innovation now are harmonizing and causing even a turbocharged, it feels, of late on this pace. And then, of course, Matt Ridley, the British guy, he says it in a way, the cocktail conversation, that you'd remember this, ideas mimetically combining, having sex with each other, is what it's all about. We are just the vessels of those ideas, much in Dawkins' sense of genetic selfish gene argument in the selfish meme argument is we're just vessels for ideas. We are the propagators of those ideas. To the extent we lower the friction of propagation, we'll just have more ideas cross combining. And that's what is the history of the world. Now, I like this also because, well, I mentioned earlier that Moore's law that is exogenous to the economy. Brian Arthur, an economist at Santa Fe Institute, actually argues that it is the source of all economic growth. That this fundamental driver of technology advancing and idea space and just innovation and progress is it's kind of interesting as a prime mover, if you will, from an economic point of view. I'm trying to be as controversial as I can, in these statements, because I'm sure there's got to be people who've thought more about this. Okay, now let's switch to a little bit more of a deep dive into why I think this is interesting and some of the attributes of machine intelligence going forward. The first is there are a lot of things that you might not think of necessarily as all being in the same bucket, but are fundamentally the same in my opinion. Biological evolution, some of the stuff that new kind of science by Wolfram would write about with cellular automata, that diagram on the top right. Something that had been explored earlier in genetic programming, basically combining code and combining designs in a way where you could design antenna like this one that would work better than any human design in a NASA program. And similarly, of course, neural networks, generative design, like everything Autodesk has been promulgating. The output looks just like that, motorcycle truss, looks organic, looks lifelike, is difficult to replicate in a normal design modality. It's sort of, if you will, outside of the design methodologies because you've grown the solution. You've used an iterative algorithm, think biological evolution, variation selection over billions of iterations. You accumulate complexity over time, but here are the important side effects. A, you can transcend your antecedents. In other words, it's the only proven way to build something more complex than everything that came before it, right? We are an existence proof that you can create intelligence through a simple algorithm iterating over billions of years, or millions of years in our case. Sort of obviously gives confidence to the people pursuing synthetic versions of the exact same simple iterative algorithms that why wouldn't we get to a future where we have something greater than human intelligence? So for example, as a thought experiment, if I said, how many people in the room believe one day we'll have something that is smarter than humans today, smarter than any human today, so smarter than the human race? And there we go, of course, some of the tech folks, but I left an important part out. I didn't give any time frame, right? So give it 1 billion years. Biological evolution should get us there. It would be a very bizarre, and humans sometimes have this sort of a selfish sense of supremacy, like evolution, just the buck stops here. Like from here on out, no more progress, right? Like how could it possibly be better than me and Trump and everyone else, right? But it can, believe me, it can get a lot better, and it should. Right? Hominids should continue to evolve. So once you sort of relax that assumption, like, well, wait, why wouldn't these other modalities get there more quickly? And that's where people can debate the time frames, but not the inevitability that we would get there. So one other side effect of all these, the artifact of creation is inscrutable. Just like our brain, the information networks in particular within these artifacts, no one understands how the human brain works from across the layers of abstraction, like tweak this nerve or this synapse and create this, let's say, psychological effect. Similarly, no one understands the neural networks of today that are of any complexity of interest. So once you've gotten to a point of it does something useful, like pattern recognition, radiology applications, or anything you'll hear from our next speaker, it gets to the point where the inner workings of these neural networks are completely inscrutable. They're only understandable as a black box defined by their interfaces to the outside world. And that's really important because engineering teams get very uncomfortable when a little bit of the code is this and the rest is not. Managerial levels don't fully understand this. It's like these practitioners are like magi that are producing this magical stuff that is within all these companies doing superhuman tasks almost everywhere it gets applied. Initially around the sensory cortex, hearing things better, translating things better, seeing things better, recognizing things better in images than a human. And yet the product of creation is inscrutable. And I'll say that here in a moment. I'll say a bit more about this. Denny Hill is a computer scientist in his closing chapter of a computer science book, I think summarizes where this is heading. We are entering a new era in engineering, for those who can't see it, basically allowing us to design and create more than we can understand. And that already has happened. This book is about a decade old. People and the practitioners in the field are already creating artifacts, complex systems, that exceed human understanding. And that's the norm here. And it's the majority of code at Google. It's how search is done at Google. It's how every single product at Google does what it does, especially if it feels magic. Going way back, I started a PhD actually in neural networks in the late 80s, Professor Ajay at Stanford, and there was nothing in the computer science department at all in this. It was in the psychology department. I didn't go very far. I only went 2 quarters, so I can't say I became a practitioner, but at least had a taste of, wow, how different this is from anything else I'd learned in electrical engineering. And in a way, it's not that different today. The name has changed, deep learning, machine intelligence. I like machine intelligence because it's like the whole gamut. It's still an iterative algorithm. In fact, I'll show you. It's still, a bunch of things connected together. But what's changed is you have a lot of data on the internet with both, people tagging things as well as just simply access to data. You have some algorithmic advances, certainly. In fact, more and more are accumulating. Different ways, different reinforcement learning, you name it. But the underlying thing of an iterative algorithm, backpropagation of feedback and such is so much similar. And most of all, perhaps, is synapse scale, meaning how much compute do you have? Back to Moore's law, right? So the neural nets of the 80s, when I was there, you might have had 1 to 10 million of these sort of synapses, meaning connections between nodes, weights in your network. When the Google brain found cats on the internet by just looking at YouTube videos without any labeled data, just watching like an infant would, watching data, discovering that, hey, this cat thing is a big deal and recognizing cats, that was about 1 billion. We all have about 100 trillion synapses in our brain, and when we were born, we had a quadrillion. We had like a 10x pruning on the use it or lose it kind of basically the way we bootstrap our intelligence, right? And the way we develop these neural nets is very similar. You overwire to start, you train them on existing data sets, and you prune like heck, and then you do compression and remove all the dead weights, and you end up almost like an infant becoming a teenager. It's like parenting. The thing you created, you don't understand. If you want to make a better one, you usually start over, right? Right? Have another kid. You're like, that product is shipped. And the process of learning and the locus of learning is on process learning. How do I make one? What are the hyperparameters I might tune? How do I want to introduce variation? Not the product of creation. And that's really important. Process, not product. And that, I think, is metaphorically what's happening in engineering. In fact, I would argue machine learning / deep learning / neural networks, this whole thing, is the biggest advance in how we do engineering since the scientific method itself, which first gave us the opportunity to accumulate learning over time as opposed to random quack ideas like, I believe in crystals, or I believe in astrology. Like, well, how do we actually accumulate knowledge over time? Scientific method still goes down as like greatest hits of humanity in terms of conceptual space, sort of that meta idea that like pollinates through everything, right? This is almost that good, or at least that's number 2 in my book. Okay, only thing I want to mention, because I mentioned it before, is all of these are learning machines, and I think I've already made these points. The only one I'll add is this domain-independent point that is kind of interesting from a business perspective. That when you're really good at this, these magi's I put it, they can do anything, right? They could go choose to work for SpaceX or Tesla or go cure cancer or work on drug discovery with Atomwise, or they could do whatever, because the ability to build these brains that do well is more of a data scientist kind of tuning than it is. In fact, you don't want to have a lot of domain independence. When Franz Ock was doing the best Google Translate work at Google, he prided himself that no one on his team spoke the languages that they were translating. They really didn't want to encumber themselves with linguistic knowledge. And when they apply these techniques to things like radiology, and within a month or 2 do better than humans, and in some cases do better than the best humans, they again pride themselves that they're not infusing into the process that prior domain expertise, which has profound impact, of course, if you think about it from labor markets and the transitions that are happening, let's say, in pathology and radiology and dermatology, when like domain expertise is an albatross, not an asset, and when the people you're trying to hire could choose where they want to work and probably choose to work for the place they're most passionate about. And helping ad matching and yield optimization for banner ads and social networks is not that thing, right? They'd much rather save the world. And so the best and the brightest folks are having this incredible labor market arbitrage like I've never seen, where a little bit of training to learn this stuff, it's actually not that hard, leads to massive outcomes in salary and in employability across just about every industry. And the industries that are boring and very pedestrian are having a hell of a time recruiting the best talent, because like they could go work anywhere. They're not beholden to their industry. Here's some of the examples we invested in over the last few years. I'll let Adam Wise at the bottom, they're obviously the best coming out of CDL here in Toronto, but a variety of areas. This is just a tiny subsector, but I just want to give you a splash screen of like, here's some of the areas we thought, this is kind of interesting. You can actually make a difference in an industry that hasn't, well, put it this way, where this is the locus of advantage. And I might argue that just like the internet and mobility infuses almost every new business today, like it'd be really weird to start a new technology business that ignored the internet, ignored mobile phones, like whatever it is. That'd be strange. Soon it'll be strange to not have a machine intelligence component of whatever it is that you're advancing. It's like, why? How could you be modern and relevant and not have that as a part of your business plan? I just want to just say one thing. It's just kind of like, whoa, Jesus, like a left-wing binger. I went to this Goldman private conference where my wife Genevieve used to work, and they have all these speakers, and like there was this room that almost no one was in at the time. It was a company called SenseTime. No one had quite realized they just raised $2 billion. And this guy, co-founder Bing Xu, was bragging like I have not heard about how China's just going to kick our ass in AI. And his arguments were very unfiltered. He said we have the biggest, 15,000 GPU cluster. We have, the most published papers. But most of all, we just get away, or he didn't use those words. He said, we do things you would never consider in the West. So we are installed on 410 million cell phones. We use all the facial recognition. We're now 100x less error rate than any other facial recognition algorithm. We're now using that in banking, in security cameras. His culmination of boasts was, we predict crime before it happens, without any reference to Minority Report. It's like, we can tell when people are in neighborhoods they shouldn't be in. We send the cops in advance of them committing a crime. They said things like, we have liveness detection. I'm like, why do you have liveness detection? Like all this bizarre stuff. And they're just, so what's my point? Imagine the competitive landscape where having the best data might make a difference. Take medical imaging with HIPAA rules in the United States, limiting almost everything to the point of crippling the data sets that you'd want to use for medical imaging training. And China is like, what privacy, right? We're just going to take the biggest data sets. And so there's a number of areas where I worry that we'll have a tough time if we, not that we shouldn't do these things, but that these are not level playing fields on access to data. I'll skip this one, but just basically they were arguing that they're second biggest in terms of published papers in the top 3 vision conferences. Those are just the companies highlighted. Universities are included there as well with CMU, Stanford, and Berkeley, and 1, 2, and 3, according to them. I have not vetted this, but this is what they claim over the last 3 years. Okay, one last thing, and then I'll wrap up. But the last topic I want to share is how this whole field of machine learning, machine intelligence is about to go through a massive explosion in power and computation. Because if you think back, every order of 10 magnitude in number of synapses, you could imagine a progression of like a mouse brain equivalent, a cat brain equivalent, a dog brain, a human equivalent. And then it's just a hop, skip, and a jump to 10x a human, or 100x, 1,000x a human, right? If you assume A, Moore's law continues, that's why that first slide's so important, and B, is there something about the way in which these algorithms map to your computational substrate that has been hindered in the past? It has. Uniprocessors, single core processors are the worst for the biomimicry of the brain. If you just think about what are people doing in machine intelligence, they're trying to copy the brain. Slow, analog, massively distributed computation with a 1,000 to 10,000x fan out of the number of synapses per neuron, right? So this is the exact opposite of our chips, where you have like 12, maybe going to 20 layers of metal. It's only like 2.5 dimensions. You don't have 3 dimensions. You have very limited planar constraints on what's wired to what. And the later breakthroughs have been using like routing algorithms from Juniper and Cisco to try to create the illusion that you're connected fully, but you're not in these cross-point switches. So you fundamentally have been limited by silicon in realizing the potential of neural networks. And so what's changing? Well, over time, you've seen this progression already. We were investors in a company called Nirvana. There's others like Cerebras who just released a 1 trillion transistor chip for neural nets. And generally, what they've realized, much like the Bitcoin miners who went through the exact same thing, start what's easy, some custom coding, really custom coding, custom silicon, is you get an advantage worth having if there's enough computation over here that matters. And it's usually the same thing. You're doing a matrix multiply and add over and over again. That's like 99% of all the computation underlying this. And so if you just do multiply 2 numbers, perhaps not 32-bit floating point, maybe they're just 8-bit integers, for example, do it wicked fast, a lot of local memory, make it like the brain. Okay, well that's going in a few directions. The digital chips are all hitting. There's over 20 startups doing new digital chips successfully, and many more that probably won't succeed. Then there's some new things that are kind of funky. The analog one, I'll just mention, we know of at least 2 companies. We invested in the first one called Mythic that is just now taping out and producing products that basically use analog compute. They take a single transistor and implement 8-bit multiply and add in a single transistor in a flash memory array. It's kind of mind-boggling. Anyone who's really into that, I'll tell you later how that works. But it's a 100x step forward in speed, power consumption. So you basically push intelligence to the edge, kind of like our sensory cortex. Imagine every camera, sensor, device, light switch, you name it, the thing in your house had intelligence embedded within as opposed to in the cloud. This is how the Internet of Things is going to propagate. Another breakthrough, it was alluded to, D-Wave, the Canadian quantum computing company, the world's leader by every metric you can imagine. Sales, customer count, number of qubits. Just yesterday, announced their first sale of the 5,000 qubit machine. These qubits are just in a very, very high level hand waving sense. Imagine they're like a 0 and 1 simultaneously, where rather than exploring iteratively all of the possibilities of a certain search space, you can sort of tunnel through and get to the right answer almost immediately. The physicists who try to explain how they work do so in ways that make everyone's head explode. So there's two camps. Those who don't try to explain it, they're like, I don't want to talk about it. And those who do, and it's really bizarre. They'll say things like, the only way to explain the power of these computers and why they're unlike every other computer ever attempted on Earth is that they evoke parallel universes and the computational resources refracted across parallel universes. You can imagine hard to compete if you just have one universe at your disposal. So like that's kind of like a pretty bold claim. And sure enough, David Deutsch and others out of Oxford predict that in the near future we'll have computers, that fit in a corner of this room, cost way less than $10 million. Let's say $1 million in terms of cost, and outcompute everything on Earth combined, times a trillion. For certain problems like constraint optimization problems, QO problems, things of that sort. That is mind-bending. It turns out one of the places they apply really well is in machine learning and machine intelligence, in variable autoencoders and a variety of areas, but that research is just beginning. The software layer is taking a while to catch up with the physics, but that's yet another reason why, wow, we may not have seen anything yet in this field. Then last point before I end. I remember I talked about ideas combining like never before, this mimetic recombination. Well, imagine half the world isn't part of the global economy. The next 4 billion who don't have broadband and don't even have internet, arguably. Bringing them online within the next 2 to 3 years would be probably the biggest influx of new folks who weren't meaningful part of the economy to being part of the economy than we've ever seen, either as a percentage of population or in raw numbers. And I'm talking about the people who aren't connected. And so, like hundreds of these satellites going up this year, many thousands next year. There's a stack of them on the left. 60 launched at a time, a terabit of aggregate bandwidth every time they launch one of these rockets. And these rockets are getting really cheap to launch. So it's going to blanket the planet, ubiquitous broadband everywhere. And what on the ground it looks like, $200 phased array antenna that lights up a whole village or a school or whatever. So literally a $200 ground station anywhere on Earth can get broadband, gigabit up, gigabit down. That's going to be game changing, right? And that's going to dramatically increase the number of people who could do online education, compete for programming jobs, be part of the global economy, and cross-pollinate ideas like never before. So ideas are going to have sex on a planetary scale. So let me end it at that and say thank you. I think it's an incredibly exciting time. This stuff is mind-bending. It has all kinds of implications on labor markets, on the future of work. I know you guys will be talking about that some tomorrow as well. And Jurvetson and I have been trying to get our heads around that for many years now. But I think it's super exciting. It's never been more exciting, and that will be true each and every year. So let me end it with that. Yeah.
Okay, so we have time for a few questions. If there are questions, anyone?
Yeah. Sure.
That was a fantastic presentation. You did a nice job of sketching out the potential. Could you talk a little bit about what the frictions are? You started to get this when you talked about China, and maybe there's some regulation might be one of those frictions. Can you just talk about maybe the sort of different classes of frictions that you see, and talk about which ones you feel like you want to keep an eye on?
Yeah, I'll mention some that jump to mind, but I like the way you phrased it because there's probably many more that I'm not even thinking about. The first that jumps to mind is concentration and power law effects. Very few companies are making a meaningful difference in this field. If you think about Google Brain and the aggregate research talent there, for example, within the US, there's probably, although I don't have the data, but I'm going to bet on some publication sets I've seen on like who's publishing those papers as a proxy for this, that there's a power law in capabilities. And what would it feel like if one or two companies made an advance well in advance of anyone else? I know Elon is deeply worried about DeepMind, and in particular that he believes they have the strongest AI globally right now. It's kind of under the covers, and what's it really being used for? Is it all this medical work they talk about, or something else? So whether it's quantum computing or just the best AI, in quote marks, whatever that means, it's not widely distributed naturally. Second thing that relates to it, and maybe these cross-pollinate, is where do you have the most data, right? So you can now imagine in retrospect why it was brilliant for Google to give Android for free, even if there was no prospect of a business model tied to it. Like we will never, unlike Microsoft, where actually Google is very much like Microsoft, but as opposed to being very blatant about, well, we'll screw you later by taking over all the good apps. Imagine they just continue to let it be free, but they get all the data, and all their terms and service agreements say we can do whatever we want with your data as long as it's for the use of improving our product. So by definition, they can use all the data and all the data streams they have to improve their suite of products, which they bundle with wild abandon. So I do worry that And when we invest, we of course ask the question, like, why would startup X have a better data set? And we've really ground to a halt on some of the medical imaging ones, where even if they have a great partnership, one or two research institutions, how do we really know they got the most data, the ones that have been annotated properly, given all the errors, frankly, in human annotation of various data sets in the medical field? Just data quality, data availability, and democratization of that is a big friction point. Regulatory pushback, of course, jumps to mind. Certain fields, autonomous driving and others, you could imagine, depending how things go, you'd have fearful, kind of like when an airplane crashes, people are more fixated on the spectacle than the statistics. You could imagine that happening through a variety of fields where you could make a positive difference, but one or two errors, and the one or two errors is what people fixate on. Policy making, short-term thinking is like, wow, that should probably be number one. Like, I don't know of any policymaker that thinks out 50 years. And I challenge them to think out 500 years, because the farther out you look in technology, the easier it gets. So the weird, at least for the kinds of predictions that I would want to make that are meaningful, like all vehicles will be electric, all vehicles will be autonomous. That is not debatable. Like, that is absolutely true. Now, debatable is what happens over the next 5 to 10 years. By 50 years, has it really percolated? What's the replacement rate? But long run, we are not going to be burning fossil fuels, right? We are not going to allow humans to drive these death machines around roads. It's like, that's absurd. We won't slaughter animals for meat. There's a lot, like, that is crazy that we use a third of all usable land on Earth, and China's growing demand will destroy Africa if we don't change how we make meat. So think long term, think 500 years, think of an inevitable future change back to the present. Policymakers can't even think 4 years, right? Like, we got on the moon by 2023, set up the Pence re-election, like, oh shit, right? That's where their mind is at, not really exploring space. I don't know, probably some more there. So human biases, I mean, I read a lot about this ever-growing bifurcation of understanding of the black boxes and technology that we live in, right? There's a few of us that understand what's going on in technology, and the vast majority don't. And what do? You sometimes opt out of the modernity. The drumbeat of progress is now becoming, years. If you just sort of opt out at a nation state level, a city level, individual level, or at a company level, you can get obsoleted really quick. And what do? You subscribe to other belief systems as to where meaning is and where humanity should go. And I think I think we're heading to an inevitable future that will look like much of the human past, where most people don't have jobs, where the vast majority of work is done by machines, which are effectively our robots or slaves for a period of time. And that's like most of human history, serfdom and pre-industrial era. A transition from here to there, like, what does it feel like when you go through 60% unemployment, 80% unemployment? Does anyone think about policies of, Maslow's hierarchy of needs and the food, shelter, water, clothing, education, and healthcare for everyone? There's absolutely ways you could imagine getting from here to there, but I doubt any policymaker is going to put a stake in the ground to get us there. So I don't think it's going to go well.
I just want to end on that one. So we'll take one more question. We have time for one more question. If there's one, please.
So I completely agree with your characterization that the computer scientists believe that the ideal world is that nothing is domain specific, and in fact the human doesn't need to do anything when implementing these algorithms. They don't need to know the domain, no knowledge. They can just use the black box off the shelf. But I guess almost 100% of the companies that I talk to who are trying to actually implement on things beyond, optimal character recognition, whatever, say their biggest impediment is that they've hired a bunch of people who believe they don't need to know anything about the domain, and then they fail. And the failure modes are about things like, well, the model, actually we could have done almost as good as this complicated neural net in the short term, but then the model that's simpler is more stable, is more interpretable. It's easier to understand, which features are important. It helps them invest in the right types of innovations in the future. And so on. But then, in fact, like which simpler model is best might really depend on the structure of the data, whether it has monotonicity properties or whether it's like really high, super high dimensional or not, and so on. And so I guess one answer to that might be, well, we're going to figure out what all these things are, stability, unbiased image recognition, and so on, and we'll build those into the general toolkit, and eventually you won't need any domain expertise for that either. Another view would be actually, like each domain has different trade-offs, and the best things and the most important things depend domain by domain, which would say that for this to really diffuse through the economy, you're going to need like a lot of specialist vertical knowledge across the board. So you kind of presented a little bit one side. I'm sure your view is a little more nuanced. So could you just respond to that?
Misled. I didn't mean. Thank you for the question, and I think in answering it, this might be a good segue to a case example with our next speaker. But let me first say, I don't mean to imply that the CS people love this, the opening part of your comment. I meant to comment, it's just a phenomenon that I'm noticing. And whether people like it or dislike it could be a different thing. And I'm not sure there's a uniform CS perspective on this, the CS people versus everyone else. Within an engineering team, there are huge differences of opinions, and certainly within a company, they're huge. So we're just talking about within engineering, and then that subset of engineering that some cases maybe one or two people trying to operate within a larger context that's more traditional engineering that are doing, let's say, the deep learning work. And so when someone's adding their first data scientist or adding their first machine intelligence person, there they can try to bring someone in the fold who wasn't a domain expert, but everyone else in the company is. So classic examples of where that domain expertise can save your bacon is, transforms of the data sets initially, right? So imagine, pick any simple to imagine medical imaging task. What frequency bands, what data is noise, use the accumulated knowledge to say we're probably gonna want to train on this kind of a data set, not just feed random stuff in at the wrong resolution and the wrong, almost just think quite simply, what inputs are gonna be relevant, and that's gonna be driven by human knowledge. So I guess the point I might make is there's both a slight disconnect that you need this, per your point, to do well, and the folks doing this aren't directly baking it in. Like, in other words, you don't constrain, other than your inputs and your outputs, you don't constrain how the innards are gonna end up. That's generic, and optimizing that over time is something that you want someone who knows, how do I optimize the brain to learn domain-specific stuff for a specific case, and all kinds of watch-outs, like am I incorporating bias or fragility. There's many examples of fragility and overfitting, or the whole thing collapses because you just weren't thinking about what you're doing well, and so forth. So maybe I'd use your question to say I kind of agree, and that currently it's a huge point of friction within the engineering teams and within the companies. Imagine you're a government contractor and you have to prove that your neural net doesn't induce a fatal situation, or you're trying to approve loans. I mean, this would be a great example. You can't do this, right? Approve loans for mortgages, and now prove you don't have bias. Well, how do you can't, right? There's no way to dig into it. Some people are working on that, but I don't know that they're gonna be successful other than the really neutered networks in terms of their power and capabilities. But there is good work going on at SRI and a variety of places trying to solve that problem. So maybe they will. Maybe I should say, I hope they solve that problem. But at the end of the day, the thing that's created, you need to test against your benchmarks, and oftentimes you go back and you iterate, and the human is still in the loop. Folks who understand the customers are still in the loop and speaking their vernacular, if nothing else. But maybe I'll use that, I think might be a good segue to Abe, because he's a great example in a field that's super important and probably has wrestled with many of these things firsthand. Good. Thank you.